All right, everyone, let me see if I can do a little better job at this than I did yesterday. So as this blue circle rolls around the inside of the red circle, that point that is on the blue circle rotates clockwise around it because the wheel is kind of rotating clockwise. It's rotating counterclockwise around the red wheel, but itself is rotating clockwise. So at this point right here, that point on the blue circle has rotated 90 degrees, but the blue circle itself has not rotated 90 degrees around the larger circle. It's actually less than. And so that little distinction is going to be important when we derive the equation, because what I'm interested in is what is the equation, the parametric equation of this curve. And it won't go all the way around because it only goes about halfway through, because I'm only going to 2 pi. I probably need to go to 4 pi or 3 pi. So let's see if we can figure this out. So in Notability, I have this here. And what I'm going to do is I'm going to draw a line from the center to that point right there on the circle. Now this angle here, that angle will be t. And that's the same as that angle right here, that angle right there is also t. Now, I don't know what this angle is. I really wish I knew what this angle is right here. I don't know what it is. I'm going to need that to find the equation. But I can find this angle. So, for example, this angle here I do know because I know how far the circle has rotated. So let's call that angle, I'm going to call that u just for kicks. And this part here that I have rotated around would be then u minus t. So we'll come back to that as well. So, and we all talked about this yesterday, that this part of my circle, so that part has the same length as that part. So what that means is that the radius of the red circle is 5. So 5 times t, which is the angle that the blue circle has turned, must be the same as 2 times that larger blue angle u. So 2 times the angle u. So we'll use that in a second as well. But so let's go back. So what we're going to need to do first is we're going to need to find the path that the center travels on. So the x-coordinate as a function of t, the center of that circle travels on this curve. It is 3 cosine of t, and the y-coordinate, or the parametric term for y, is 3 sine of t. And then this point here, this point moves clockwise around the blue circle. And again, that has rotated when the blue circle has rotated through t radians. It has moved through u minus t radians from this kind of a starting reference point. So that is going to be a plus 2 cosine of u minus t. And since if it was sine, it would go up this way, but it's going down this way, so it's going to be minus 2 sine of u minus t. And now this is where this equation comes in. U equals 5/2 t. And so I could plug that into these equations up here. And then when I simplify 5/2 t minus t, that is just 5 minus 2 over 2t. And so that allows me to simplify this expression a bit. And so what I will do is I will go here. Let's see. So the x-coordinate is 3 cosine of t plus 2 cosine of 5 minus 2 over 2t. And the y-coordinate is 3 sine of t minus 2 sine of 5 minus 2 over 2t. And that is the parametric equation of this function. If I change that maybe to, say, I think 4 pi will probably do the trick. If I change that to 4 pi, I got to change other things. I need to change other things in these equations. So for example, I need to go down here and change that to 4 pi. So I will change that to 4 pi. And I think that's going to be okay. So yeah, there you go. Now it traces out the entire path. So for future reference, what you'll have to do next is you'll have to derive the curve as the circle rolls on the outside. So I did the one for the circle rolling inside. You'll do the one for the circle rolling outside. We'll talk more about that today.